Greetings from Michigan. Welcome to Getting Started with VR Development. My name is Tom Petro, and I'm the Business Development Director here at Innovative Learning Group, and I'll be your moderator today. We're really happy that you could join us. For those of you who are new to our company, ILG, I'm just going to give a brief overview. ILG designs and develops custom learning and performance support solutions. We've been in business for 14 years, but many people on our team have been creating learning solutions a lot longer. What we really care about and what differentiates us is our focus on performance and helping organizations reach their business goals. So for us, it's really all about performance first. We work with a diverse group of medium and large-sized companies all across the country, and some of which we also serve on a global basis. Overall, we have more than 140 clients across 35 industries, with more than half of them doing work for them outside of Southeast Michigan. Matt is ILG's Senior Director of Technology and Visual Design. He provides leadership for ILG's programmers and graphic designers. Matt brings the latest advances in digital capability to practical application and learning, including augmented and virtual reality. He was named a 2017 Learning Champion Thought Leader by eLearning Magazine. So with that, let's get started. Matt?
All right, thank you, Tom. I'm delighted to have the opportunity to present on virtual reality today. Let me jump right into the topic here. And given that we probably have folks with a wide variety of backgrounds in VR experience, I want to just level set a little bit and look at the differences between augmented reality and virtual reality to make sure everybody has an idea of what those differences are. So I'm going to point out here the two devices on the left are the kind with glasses that you could see through. And on the right, you've got some headsets that you can't see through. And the middle, we have an iPad there. And so if you would take some time and enter into the chat, what are the differences between augmented reality and virtual reality? All right. And as those are starting to come in, the real distinction is with AR, you see the real world, and the device adds to what you see in the real world. And this typically means it's good for performance support because you can get real-time information just while you're doing something. In virtual reality, it blocks what you see in the real world, and you're immersed, and you have then something that's good for training where you can practice doing things ahead and learn it, and then you come back and you're not using the equipment at real time. And I see coming in and starting to match those things exactly. Immersed during VR and digital content overlaid in the real world with augmented reality. So that will be something to keep in mind as we move forward. We're going to mostly focus on the virtual reality side of things today. Now we have a fairly ambitious goal for this 1-hour session because we're going to be looking both at why you might want to use virtual reality, and there's some to talk about there, and also how you go about developing virtual reality. And there we could talk for hours and hours or days and days about that because there's so much to talk about how you would go to put together developing virtual reality. But we'll focus first a little bit on the why because there's really no point in the how if we don't have a why for why we're doing it. So we're going to think about good learning applications for VR. And the reason why we want to think about this is because we don't want to use VR just for the sake of the new technology being there. So no benefit to just pick a technology just because it's cool. We really want to use VR in the cases where it will make a difference and you can learn from it appropriately, and it's something where you need VR. You couldn't just do it in an easier way without VR. With that end in mind, this slide shows some spots where virtual reality makes sense. On the left-hand side are industries where it really makes a lot of sense: healthcare, manufacturing, sales, law enforcement, military. On the right-hand side are spots where what you're trying to do needs virtual reality. So a case there would be if something is too dangerous to practice, or if you cannot afford to fail, like people's lives are at risk, or something that's too expensive to simulate, or places where it's bulky to move equipment. So maybe in order to set up something, in order to practice with it, you have stuff that's thousands of pounds equipment and you'd need forklifts and cranes and stuff to move stuff around. In virtual reality, all that stuff can look and work like it really does, but set up takes no effort. Virtual reality makes sense, where it benefits from repetition over and over again, practicing and practicing and practicing. Like you could do that in e-learning as well with practice over and over, but with virtual reality you get the benefit of practice over and over, but it feels like you're in the real world when you do it. You could combine that benefit from repetition together with randomized practice scenarios so you can handle all the odd cases that might come up. And another spot is benefit from immersion or role play. And you might do that type of a role play with just one person in VR with the rest controlled by computer, or you might also do that with a multiplayer VR where different people are playing different roles during the simulation and all together in the same virtual environment. So I wanted to give some backdrop here about where virtual reality makes sense, but again I wanted to come back to you and I wanted to give you a little bit of time to think about how might you use VR. Enter in the chat places where you think virtual reality might make sense, and I'll give you a little bit more time here because that might take a little longer to type. So I see one come in that said high consequence training. Yep, that makes sense. It aligns with the cannot afford to fail. I see police officers, firemen, aircraft pilots, VR store to simulate a store setting. Orientation of new hires, that's a good one. We actually had a podcast where we talked with one of our clients who's used VR for orientation. Research institutions, that seems like a good candidate because it could be spots where there isn't any way to do it without VR. Expensive structures. And that reminds me, if there's something that you want to train on, but it just doesn't exist yet, like perhaps you're building a new factory and you want to train people about the factory, but the factory doesn't exist yet. You couldn't do that in an easier way without VR. All right, some great ideas there. This might be a good spot for me to take questions you have about how we develop VR. If you want to put in your questions, I'm going to keep going, but we'll come back to look for them in a little bit. This is going to be also the spot where we've completed our whirlwind tour of the why of VR, and we're going to transition over to how do we develop VR. Okay, and there's one question here about how can we track VR, which that's actually a good question because in virtual reality, it isn't the type of thing like we're going to log into the learning management system and browse through the learning management system catalog and launch the VR from the learning management system. There has been ongoing for a while the XAPI, or you may have heard of the earlier code name for it, the Tin Can API, which is meant to be able to track informal learning in general. And that will be perfect for virtual reality because you can start the training experience in the headset and launch it however you want to launch it and still track the results to your learning record store. I see a question here also about what types of skills do you need to develop VR apps? And we're going to talk some about the tools that you use, but at the high level I'd answer that by saying that you need the same types of skill sets you need to develop e-learning and mobile learning and that sort of stuff, but just different specialties. So you still need graphic designers, and you still need programmers, and you still need instructional designers and project managers and editors, but the type of graphics you need might be a 3D modeler instead of someone who knows how to use Photoshop and Illustrator. And in the coding, I'll talk more about the tools in a minute. How do we develop and deliver VR? We need to pick a delivery platform, and that is the equipment people will be using. And that's important because the tools that you might use might vary quite a bit differently depending upon what equipment you use. So we'll delve into that a little bit in a minute. And the programming and graphic tools we're going to look at for the content development. This chart shows prices, and I guess my caveat would be here that these are prices as of the last time I checked, which was the last time I gave another version of this talk before. There may have been some changes, but it's good enough for a comparison and to see the huge range. So the cardboard viewer that you might buy and attach to your phone might be as little as $5 if it's not branded in some way. It's just a cheap cardboard viewer. And then what you see at the bottom are things where we shift out of virtual reality to augmented reality type glasses, which are a good bit more expensive. But at least this gives you a feel that if people say the equipment for virtual reality is expensive, you've got to zoom in first to figure out whether it's $5 expensive or $6,000 expensive. The other point that I want to make about the cost of the equipment that is needed is that It changes dramatically over time and very quickly. The consumer version of that HTC Vive, which is listed right now at the $599 as of my last check, I got originally for Christmas, not just last Christmas, but a year before, and it was $899 at that time, so you can see it's come back down quite a lot. And what I like to do to illustrate the cost of how technology comes down is to talk about my own family. My family is 4 people, my wife and I and 2 daughters, a 6-year-old and a 9-year-old. And if I look at 6 years ago, our total technology kind of in this space was 2 laptops and 2 flip phones. And now I have to refer to my notes here to tell you how it's changed over the last 6 years. So now we have 4 tablets, 3 smartphones, because my oldest daughter managed to get one, an Apple Watch, a Fitbit, an Apple TV, a Roku, a Smart TV, an Alexa, a Chromecast, an HTC Vive, and 2 Google Cardboards. So that's how much technology has changed for our own family. And if we look at our first iPad, the original one that we got was $499. At the last Amazon Prime Day, we got a Kindle tablet, which can do pretty much what the original iPad did, at least for our purposes, $29 versus the $499. So if anybody approaches you saying we can't do VR because it's too expensive, there's a lot of fronts you can argue that it's not always expensive depending upon the equipment now. And you could also just say, who cares if it's expensive? This time next year it won't be, because it's headed in that direction. The next thing I wanted to talk about is tools that you might use to develop AR and VR. And whenever I talk about tools, whether it's for e-learning or mobile learning, I like to use this chart that divides into formatting, authoring, scripting, and programming, because it helps categorize by type of tool. So further to the left is simpler to use tools, but less powerful, less interactivity, less capability. And further to the right is more interactive. So if we looked at the far left side, tools for putting together a 360 video where you could just look around. You could get a 360 camera and walk around and take pictures, but then you can look wherever you want with a virtual reality headset, but you can't do things. You could step that up maybe one level by having trigger points that you could click to load to a new video or to pop up a video inside or something like that. In the authoring category, there's a tool called Nomal that I ran into at the Realities 360 conference last June, and it allows you to create kind of cartoon animations that can be played back in virtual reality. Rasma is a tool for augmented reality that lets you take a picture of things and make it into essentially a picture of anything becomes a QR code, so when a camera sees that thing again, it can pop up some information. And then in the middle, there's WebVR, and on the far right, which is where I'm most interested from the interactivity standpoint, the top 2, Unity and Unreal, are 2 of the primary tools used for virtual reality, and Vuforia, ARKit, and ARCore are toolkits for developing augmented reality. For Unity and Unreal, I'm going to focus in on those a little bit because they have 2 of the longest histories for developing VR. And the interesting thing and exciting thing about that is that they didn't just spring up because VR is here. They were the 2 tools that were used for computer gaming long before that. And so they just got add-ons to become tools for virtual reality, which means they're very, very mature tools by the time they started doing virtual reality. One of the things that's key about these tools, Unity and Unreal both, is that they have what's called a physics engine built into them, which means that they already know how to handle the physics of things in the real world before you have to start doing any programming. For instance, if in virtual reality I created a basketball and I put it in the air there, as soon as the thing started, the ball would know how to drop and know how to bounce. And I don't have to do any programming to make that happen because it's built into the tools. And then I can expand upon it from there to change it and make it work in realistic ways or unrealistic ways. But that physics engine and the capability to render the 3D graphics are what make these tools so powerful. In a comparison between Unity and Unreal, because one of the questions I get a fair amount is which one of these 2 should I use? One of the primary drivers for choosing Unreal would be if you need the utmost in graphic capability. And in Unity, harder to get a level of realism in the graphics that you could get with the Unreal Engine. Although I will say that I have seen many, many things in Unity that look plenty nice and don't need to step up another level to the Unreal level. Also, historically, one of the features that was preferred in Unreal is blueprint scripting, which allows you to do some of the coding without having to write any code. But I have recently run across tools that help with that also for Unity. If you look at the Blueprint's visual scripting language, and you see kind of the different flow diagrams they have here that triggers when something happens, these sort of things should happen. If you open that up side by side and look at the tool called Bolt, you'll get an idea pretty quickly that Bolt is doing the same kind of things now for Unity that was much appreciated in the Blueprints tool for Unreal. And then other things to consider, the asset store selection. So if you're going to go and buy existing models or existing programming, the Unity one is very, very extensive. And then another thing to think about is platform support. If I build this, is it going to run on the Vive and the Oculus and the PlayStation? And what if I also want to develop something that you could use it in VR, but it also has a different kind of component that works on apps? Built from the ground up to be whatever you build in Unity can run across a wide variety of devices. Unity is probably considered a little bit easier use for a new beginner. This link, Unity or Unreal at the bottom, has a very extensive look at why you might want to choose Unity or Unreal, so you might want to go there if you're interested more in that. Just looking at the comments that are coming in, one says Unity is easy to use, and I would agree from my own experience. I have not delved into Unreal an awful lot, but Unity I spent a fair amount of time, and it was not hard to pick up the basics. I think it's pretty hard to become an expert at everything because there's so many possible things that you can learn, but to get started is not too hard. If we start to look at what else impacts the price, aside from the number and type of headsets, level of realism, it could be also, as we're going to develop VR, do we need custom or generic models? So for instance, if I want to set up a VR scenario that's based in an office, I can go into the asset stores and get desks and chairs at $1 or $2 a model and lay them out. It's not a big deal of acquiring assets for setting up an office. But if I want to set up an operating room and it needs to be the particular equipment that's in my operating room and a model for that doesn't exist and I have to create it, there's a huge range. If you think about interactivity, if you were going to do a multi-person virtual instructor-led, you could set up some models and ability to pick up things, and then you could leave a lot up to the instructor to figure it out, and you don't have to come up with a whole lot of custom programming. But if you were going to do some kind of, let's go back to that surgery example, and we needed everything to work there, and it has to react to what's going on, and there isn't a person there to simulate another part, you could have quite an extensive amount put into just the gameplay interactivity. And then I would say also the extent of the environment, small or large. If we were in the spot where we were going to just do one room in a hospital and we needed to make that work well, that's one thing. But let's say that what we need to do is be able to move around from room to room and we need to build the whole hospital. Quite a different task than one room of the hospital. What I like to show here is an example of a cost model. But I don't want you to get hung up again, not the idea that we're getting to a real exact price. It's not intended for that. In this model, we need to first of all pick the cost for one headset, and then we'll look at the number of headsets. So we can come back to that same list I was using before, and we could pick our device. So if I were going to pick the HTC Vive, and we'll just assume that the $599 was right, then we might say, well, it's not just that device. I need the $600 headset, and I need maybe a $1,500 computer to go with it to support that price. That would get us to $2,100 for the headset. If you're thinking about using this in an organization, you might also think about, I also need floor space and a lab somewhere to set this up. I need to tack that on. However, unless you need a permanent place for it, you can really pull tables out of the way and set up a 10 by 10 square and pretty much anywhere with a laptop and just room to set up the play space, as it's called. So we're going to go right now for a factor of 2,100, and if we drag the stations, maybe we need 10 stations, maybe we need 50 stations. How much are we going to be spending on headsets and computers for people to be able to do this VR? Then we're going to figure on our 3D models. Again, are we buying a lot from the asset store and just putting it in and resizing it and rescanning it with different textures and colors, or are we building from scratch? So we could be anywhere on our range there. On our interactivity, do we just have to have stuff in the room and people can pick it up and put it down, or do we need to simulate real equipment that's there in the real world? So we could have a low or high interactivity cost. And then our big factor is that breadth and scope. once we've done the modeling and interactivity for one room that's special purpose to that room, are we then doing a bunch of other rooms that might have different equipment, different interactivity, and that sort of stuff. So hopefully, again, not to get to an exact price, but just to give an idea of the factors that impact the price when we're creating virtual reality. Okay, question here. What if we need to build VR that works across different headsets? What is the impact? Again, if you're using Unity or Unreal, you can build once and play in multiple places. But if somebody says, I just want you to build it for Vive, or I want you to build it for Vive and Oculus and some other things, while it can publish in all those places, it still is going to cause some extra work during development to make sure that you support all the input devices and everything. And definitely also in your quality assurance testing, you're going to have to test in a lot more things if you develop for more than one device. But I think that is a good question, because at this point, I don't know if you as the developer or commissioner for a VR solution are going to do it where you say, we're going to buy all the Vives for everybody or all the Oculus for everybody, and we know we're going to be on the Oculus Rift, so we're developing for that, and that's fine. Or where you might be in a spot where we're going to develop this VR solution, but we're going to deliver it out to our employees' home devices or to the general public at large. And so when we go to develop it, we have to assume that some people may be on more than one different type of device. So very good question there. I'm going to now transition over to creation of 3D graphics to go into one of these solutions. One of the things that you have to pick is for the tool for that, am I going to use something like Maya or am I going to use something like Blender? So in my own exploration, I use Blender because it's an open source tool for 3D graphics. And I did not delve very deeply into this because my expertise is really more on the programming than the graphics side. I don't intend to ever become an expert on the graphics side. Right away, looking from the interface for Blender, you can see that there's all kinds of panels everywhere on there, and you can see that if you're really going to become good at Blender, it's going to take some time and effort to learn how to do it. I did a little bit with that. I drew on my experience in college and the CAD key I used for engineering models back in the day. Before long, I decided I'm not going to do an awful lot in that graphics tool myself. And then I said, all right, I'm going to try something simpler so I can have some mock-up stuff to use in the things that I'm prototyping. I went to Microsoft's Paint 3D, and I'm going to show you a little bit about that. This is nice because if you have the latest updates for Windows, you will get automatically Paint 3D, and I can go in and if I can create some 2D shapes if I want, and once I make it into a 3D shape, I can drag it around like so, or I can go in and put in a 3D shape like a sphere or a cone, and once they're in, again, I can rotate them and so on. Let me get rid of those for a minute to make some more room. I could also go in and put in a person or go in and put in a fish. And then one of the things I like about this is the capability to do stickers. So like if I get the kind of googly eyes here and draw the eye, the cool thing is it automatically conforms to the shape of the 3D model. So I can just attach that on, and then I'll spin the fish around this way and put in the eye for the other side. You can create some things that you could use as a part of your virtual reality scenario this way. Once you have created one, you would go in and you would do a save as, and what you would do then is choose save as FBX format in order to be able to bring it into Unity. You can also draw right on the model. So like if I wanted to change the whole color of the fish, I could click on that and do the whole thing, or I could get a paintbrush and I can come and draw right on the shape. But the whole point of the Remix 3D part is that once you create something, you can kind of submit it to the store here, and then you can combine it with things that other people have submitted. So this store of models includes some things that are free and some things that people are trying to sell. So I'll go to my office chair example to search in their online store. And then now I have imported the chair, and let me get rid of my poorly drawn fish. And now the office chair, you can see one of the nice things about 3D models versus art for e-learning is that it acts a bit more like vector art does, which is once it's there, you can still size it and scale it and turn it and interact with it instead of being a flat picture that's hard to combine with other things. If you are interested in creating some simple stuff yourself, this is a great tool to create simple stuff. If you want to create complicated stuff, you would need to go to a fancier tool like that Blender or 3D Studio. And one of the things you'll notice is if you go to insert some of the other things that are created here, not everything that is created here is created using the Paint 3D. A lot of times it'll say this was created using Maya, and obviously you're going to get a fancier look that way. The next thing I want to show is if you were going to get stock models, instead of from this approach of getting them from Paint 3D, how you could get them right inside the asset stores for Unity or Unreal. So I'll take again the case of Unity. So let me get Unity open. I was just showing you could select all the trees in Unity, or you could select a particular tree. And if I wanted to insert a new item, you could see from the library all the things that have been imported that I might want to import. So you can see here actually is a fish, like the fish that I had made over in 3D Paint, that I could drag and drop it. And over here in the space, we'll be walking into that area in a minute, is the fish where I dragged it in from down here. And then what I wanted to show in the asset store is how right while you're working in this tool, you could go and browse for new components to bring in. Within their store, let's see, instead of searching for office stuff again, I'll search for road signs, imagining that I was going to do something that is going to simulate a roadway, for instance. So they have a lot of great filters here, so I can sort based on price, like I want something that's no more than $10 or no more than $20, and you can filter it down by whether it's 3D models or other things as well. And you can see for $7 I could get some road signs, a great vast variety of things that you could find in order to insert into your virtual reality. Here, when I start, I want to be able to test, but I don't have the headset on. So I can walk around in this environment. I can use the mouse to look around different ways, and I can use the arrow keys to move around. It's a little bit interesting trying to do this versus running it this way and putting the headset in, because it's quite different controlling this way and using the mouse instead of the controllers that you would use for the actual Vive or Oculus. And some of the programming you have to handle kind of both ways in order to make it work both places. With regards to the comment about whether it's easy or hard in Unity, generally getting started in Unity was easy, but then there's some things that are just tricky. Like for instance, the trees were free assets in the store, and the grass is a free asset from the store, but they're different in that the trees are really 3D models of trees, but the grass is really a bit of code that renders the grass automatically. And you do things like select how tall is the grass. One of the types of things that really has nothing to do with programming that you have to figure out at the beginning is in some of these add-ins, like what is the impact? Initially, when I set up this space, I set it up to be a 40 by 40 square instead of a 10 by 10 square. And I said, all right, I'm ready to render this out and try it on the real device. I click render, and it said, okay, it's going to be 14 hours until this is ready to use. So I said, all right, I'll take out some trees. Maybe the leaves on the trees are making it take too long. Took out some trees. It said it's going to take 13 hours and some. And then I said, all right, I'm going to take out all the trees, and it said it's still going to take 13 hours and some. It turned out that it had to do with the grass, the automatic rendering of the grass pieces. And once I changed it from a 40 by 40 square to a 10 by 10 square, instead of taking 14 hours to render, the next time I said to render, it said it's going to take 6 minutes to render. When you're just getting started and you don't know what you don't know, you could kill a lot of time by not knowing some of those little types of things that could waste a lot of time. I'm going to walk around in this space so that I can show a little bit of the interactivity. There is a little chest here, and when you click the chest, it will open and balloons will come out. And this was a good spot to learn a little bit about how the physics of things work too, because you can attach whether things are solid or not independent of how they really look. And so you can see like some balloons coming out through the chest there. And what happened when I first put the balloons in the chest, I didn't make the bottom of the chest solid, even though it looks solid in the physics of it. And so the balloons went through all the parts of the chest that way. But one thing that is really nice is that if I go and click play with what I've built in Unity, if I do have a headset connected, it will start that up right away. I can put the headset on and start using it, and it doesn't have that render time to make it look really as finished and nice as it will look in the real world when it's used. But almost immediately you can start testing it out that way with the headset. So the next thing I want to focus on is shifting away from the graphics and programming and starting to think about the design ideas and the interactivity and what we might want to think about from the instructional design point of view. So a great place to start is to go to one of the stores, and because I have the Vive, I'm going into the Steam store and browsing and looking for interactions. Of course, looking for interactions that are related to learning, but also it's helpful just to look in general at things that are available in the store either for free or not too expensive, because regardless of whether it's related to learning, there are still things where you can get new ideas and you can learn about the interface conventions used commonly, and you can also find some outliers and some innovative approaches. Once you're in a spot in VR, right, and you're looking around and walking around, you only have so far you can walk in the real world before you need to navigate to another space. And when you need to then jump someplace else, teleporting to another space, there's different conventions for how you should set that up, and some used more often than others. We'll look at that in a minute. For interactivity programming, there are some things provided to help, so you don't have to build from scratch everything that happens. Like when someone presses the button on the controller, what should I do? You could think of these as kind of like templates or models to help you get going. So if somebody picks something up, or if they pick something up and pull the trigger, how do we handle that sort of stuff? The Steam VR plugin might be something to look at for that. And you can see if I am in Unity and I am looking at models, there are spots where different pieces are attached to that are programming that are provided as a part of those software development kits. Now, I had mentioned before this idea about the teleporting, and what you see here in the lab is a fairly normal convention, which is if I hold the controller in front of me and press the top pad at the top and hold down, I'll get an arc like this, and you can see this arc shows red, which means if I would let go at that point, nothing would happen because that's a spot in the floor that I can't jump to. So those blue lines that are around it are also outlining to show that's a place I can't go to. Those aren't always there when you're looking in VR. They appear when you press that button to say that you want to teleport somewhere. And now I've advanced to show what if I was going to teleport to a spot where I can go. The arc changes to green, which means if I let go, I'll jump from wherever I was standing to that point. So that's what I would put forward as a normal convention for how do I move around in VR. Sometimes, like in this spot, you could move anywhere that wasn't encircled by those blue lines. In this case, I can't move anywhere on the mountain. They haven't really set it up to be able to do that. I could jump to wherever these little markers are that say that's a place you could jump to. But if I contrast that to how it works in immersive, it doesn't use that convention at all about being able to jump anywhere in the room. Instead, it has these little eyes, and when you pull the trigger and point the laser pointer, if you let go at that eye, it will jump you to that activity. This one is probably the more normal convention and nice if you can move around a lot of places in the room. But again, it's just nice to see that there's other ideas out there about how it could be done. There were some questions before about how do I get started learning Unity. One thing I would really suggest with Unity is before you start trying to do VR with Unity, go through some of the basic tutorials for Unity to just as if you were going to do computer games. So I went through the rollerball tutorial and the space shooter tutorial, and that gives you a really good concept of how the physics engine works and what is a rigid body and how do you attach the rigid body to your elements. And if, for instance, you have a balloon go out of the screen, how do you destroy that object so you're not wasting memory with like 300 balloons simulated that have all floated away till no one will ever see them again? Basically, you set up bounding boxes where if something goes outside of that bounding box, that model no longer exists. You will see a number of links here for getting started. Steam VR plugin, and the input utility.
Thank you, Matt, and thanks to all of you who joined us today. Our contact information is on the screen here, and we invite you to reach out to us with questions, thoughts, or further comments. And as Matt said, if he can't answer the questions that we received today on this webcast, he'll answer them after the fact. ILG is on Twitter, and we also have a LinkedIn group, Friends of Innovative Learning Group. I encourage you to join and post discussion items there if you haven't already.
And I do want to call attention also, there's a link here for the podcast, and we have a section in the podcast that addresses particularly virtual reality. I believe it's podcast number 5 you'll find after you go to that link, as well as it covers a lot of other topics of interest to learning. So thank you all very much, and I do encourage you to stay in touch, and I'd love to hear your ideas, comments, and suggestions. Thank you.